Welcome to the video on the definition of logarithms. So in the last video we talked about inverses, and this video will actually get into logarithms and what exactly they are. So let's take a look at this logarithm right here. So this is an example of a logarithm, and you would say it as log base 2 of 8, or we would say log of 8 base 2. I myself prefer to say log base 2 of 8, but it's totally up to you how you want to say it. So what are logarithms? Well, in this phrase above, this explains what exactly a logarithm is. So let's read it. It says if b and n are positive and b is less than, or correction, b is not equal to 1, then log base b of n is equal to k if and only if b to the k is equal to n. So this phrase basically, in a complicated way, gives us a relationship between a log and an exponential equation. So let me kind of break it down for you, because you're probably going, what? After you read this. So a log and an exponential equation are basically inverses. So that means that you can change between the two forms anytime you like. It's like giving a different name to a person. That's basically what you're doing. You're just giving this line a different name. You're giving a line a different name. There's two names, the log name and the exponential name. So it's saying that log base b of n is equal to k and b to the k is equal to n. These both mean the exact same thing. It's just written in a different way. So how do you convert between the log form and the exponential form? Well, as you can see here, in both of these, b, or the base, is on the bottom. So that's kind of like how I like to think of it. B for bottom, B for base. So the base is always going to be at the bottom, no matter which form it's in. And if we kind of look at this n as sort of an exponent to the log, even though it really isn't an exponent, but if you kind of think of it like that, then it'll be a bit easier to kind of see the relationship, at least for me. So the n, which is the exponent in the log, is what the exponential equation is equal to, and the exponent in the exponential equation, which is k, is what the log is equal to. So that's kind of the relationship. So let's kind of practice right here. So we have log base 3 of 9 is equal to 2. So if you write that, first we take the base, so b for bottom, 3 to the 2 is equal to 9. So 3 squared is equal to 9. So we basically converted from the log form to the exponential form. Now let's convert from the exponential form to the log form. So b for base, b for bottom, so log base b of 625 is equal to x. And this is sort of how we isolate the variable when we solve for exponential equations. You kind of turn it into a log and then solve the log. And we'll talk about solving logs in a future video. But for now, just keep it in the back of your mind, or forget about it for now. It doesn't really matter. But all you need to know is we're converting from the exponential form to the log form. Right? So why did I put this graph over here? We talked about this briefly in the previous video. And this graph is showing the inverse of the function f of x is equal to 2 to the x. So in this video, we're going to find what the inverse actually is. What's the function of the inverse? What's the equation? So the way we do that is we convert to the log form, sort of, and then we do something else. So first, let's convert to the log form. So we have f of x is equal to 2 to the x. First thing we have to do is convert this function into an equation, and the way we do that is we replace f of x with y. So we have y is equal to 2 to the x. Alright, now this looks really similar to what we have here. So we're basically going to do what we did in this problem right here, and that's converting to the log form. So log base 2 of y is equal to x. But we're not done just yet, because remember, this is just a different form of this equation right here. So basically what I'm saying is log base 2 of y is equal to x is the same line as y is equal to 2 to the x. So this is not the inverse equation. That's what you have to remember. Remember, to find the inverse, you have to switch the variables. So we have to switch x and y. So if we switch x and y, we get log base 2 to the x is equal to y. So now we've kind of solved two problems in one, because now we found the equation of the inverse, and we've also isolated y, which is very, very important. So now that we've isolated y, we can now turn this back into a function, because that's how it started. So we're going to convert it and make it f to the negative 1 of x, or the inverse of x is how you pronounce it, is equal to log base 2 of x. So the inverse of x is equal to log base 2 of x. And if we kind of compare it to this one right here, this function right here, you can see it's very, very, very similar to this right here. And basically, all you're doing is you're adding the word log in front of the 2 to the x in order to convert it to the equation of the inverse of this function right here. So you don't have to go through all these steps next time you do this, because you know all you have to do is put a log out in front and you're done. So that is basically a video on what a log exactly is. In the next couple videos, we'll talk about what we can do with the logs, and in the next video specifically, we're going to be talking about some logarithmic rules. Just like we have exponent rules, we also have logarithmic rules. So thanks for watching this video.